In the present module, we are dealing with another type of data analysis, which is known as factor analysis. Factor analysis is a technique of data reduction used in data analysis. Usually, a researcher will be collecting data on several variables during the process of data collection. And during the initial stages, he will be analyzing all the variables also. But when once such a preliminary analysis is complete, to proceed to further activities like reporting certain special features of the data and recommending certain further protocols for further selection processes or further research based on the information gathered. This bulk of the number of variables becomes a difficulty. And to avoid such a problem, a type of data analysis has been suggested, and it is known as factor analysis. And when a number of variables have been observed in data collection, and if you are carrying out correlation study and you are getting the information that several of the variables are strongly correlated. From among such strongly correlated variables, you can select certain variables which are contributing at a higher level towards the variability of the population when compared to the other variables. Such strongly interrelated variables can be subjected to factor analysis so that such variables can be classified into a number of factors or a number of groups which behave in relation to each other, in the sense that the change in some variables bring about corresponding changes in the other variables in the same factor group. So in such a way, you can classify the variables into a number of factors, and from each factor, from each group, you can select the most important variables, which can be called the lead variables. And the lead variables can be used for further studies and recommendations. So, as mentioned, factor analysis is a technique used to exploit the interdependence between variables. And there is no distinction between dependent and independent variables. Through the analysis, we get a few factors that can be called factor 1, factor 2, factor 3, like that. And the first factor is actually the largest and the most important, and it includes majority of the variables, and it contributes the highest percentage of variation to the population. And before starting factor analysis, we have to become familiar with certain terminologies related to factor analysis, and the most important terminologies are communality, Eigen value, factor loadings, and percentage of variance. And in factor analysis, communality is the quantity of variance that is shared by a variable with all the other variables. A factor means a group of variables, and in that group, the variables will be sharing their variance. And the measure of communality is the quantity of variance that is shared by a variable with all the other variables. And the next is eigenvalue. And eigenvalue, each factor will be having an eigenvalue. Eigenvalue of a factor is the total variance explained by that particular factor. And in factor analysis, usually factors with eigenvalues 1 or above are only retained for the determination of the number of factors at the time of factor analysis. So, eigenvalue of a factor is the total variance explained by that particular factor. Factor loadings are the measures of correlations between the individual variables of the factor with the factor. Since the values of the variables in a factor are strongly correlated, you can know the correlations between the individual factors of correlation between the individual variables of each factor. And the measure of correlations between the individual variables of a factor with the factor can be called factor loadings. And then comes the percentage of variance. And it is the percentage of variance or the percentage of total variance of the population attributed to each factor. The variance of the population is contributed by the factors together, and the percentage of variance in percentage of total variance of the population attributed to each factor is called percentage of variance. And the eigenvalues you can plot against the number of factors on a spreadsheet. And if you are plotting the eigenvalues against the number of factors, then it is known as a Scree plot. In other words, a Scree plot is a plot of the eigenvalues against the number of factors. In factor analysis, usually the principal component analysis method is used. Factor analysis is a type of multivariate analysis, and the principal component analysis method is usually used here. In factor analysis, you can use an unrotated or rotated data matrix or factor matrix. Through rotation, the factor matrix gets transformed into a simpler and easily interpretable one. After rotation, each variable will usually have a significant factor loading with only a few factors, or most commonly only with one factor. Different types of rotation like orthogonal rotation, Varimax procedure, oblique rotation, etc. are used based on the nature of the data. Unrotated data also can be used in factor analysis. Then we come to the procedure of factor analysis. The procedure of factor analysis involves several calculations, and it is advisable to use an appropriate statistical package for the same. The major steps involved in factor analysis are described. The first step is preparing the data matrix. The mean values of all the variables are plotted on the spreadsheet, and the data on the spreadsheet is used for factor analysis. The next step is the fixing of the number of factors to be extracted. And usually factors with an eigenvalue of 1 or more than 1 will be extracted. And then you have to decide the nature of rotation, whether you are going to use a rotated data or an unrotated factor matrix. And then the next step is finding out the eigenvalues of the factors. The number of factors is limited in such a way that the last factor is also having a minimum eigenvalue of 1. Then the next step is finding out the percentage of total variance. The percentage of variance contributed by each factor towards the total variance of the population and the percentage of total variance. And then you have to find out the factor loadings of each variable in each factor. And factor loading stands for the extent of correlation or the value of the correlation coefficient of each and every variable. The next step is finding out the factor loading of each and every variable in each factor. And factor loading gives you an idea about the extent of correlation or extent of the strength of correlation of any particular variable in the factor with the other variables in the factor. Finally, you have to find out the number of significant variables in each factor, and such variables will be showing a different factor loading, and based on the factor loading, you are finding out the lead variables. The lead variables are the variables with the highest factor loading. Then you can see an example for factor analysis. Factor analysis in the case of 20 genotypes of peperomia based on 15 variables. You are given the serial numbers of the 20 genotypes on one side of the table and the 15 variables. The names of the 15 variables are given on the other side, and the value of, or the mean value of each variable is plotted on the spreadsheet. And using this spreadsheet, you can proceed to carry out factor analysis in a statistical practice. When you are carrying out factor analysis, the first step is to extract the communalities and the eigenvalues. And of course, you have to extract the eigenvalues and you have to take a printout of the table showing the eigenvalues. And in the table presented here, the extraction of eigenvalues is shown, and principal component analysis has been used for that. From the present data, 3 factors have been extracted, and the first factor has an eigenvalue of 9.44, the second factor has an eigenvalue of 2.15 or 2.16, and the third factor has an eigenvalue of 1.56. The percentage of total variance contributed by the first factor is 62.95%, The percentage of total variance contributed by the second factor is 14.37%, and the percentage of variance contributed by the third factor is 7.71%. And you can see that there are three factors, and among them, factor 1 shows the highest eigenvalue and the contribution of the highest percentage of total variance towards the cumulative variance of the population under stat. And the second factor has an eigenvalue of 2.16, and it contributes a total variance of 14.37%, and the third factor has got an eigenvalue of 1.16, and the percentage of total variance contributed is 7.71. So you can see from the eigenvalue table that the cumulative eigenvalue, when you are taking the sum of the eigenvalues of these three factors, is 12.75, and the cumulative percentage of variance contributed by the three factors together is 85.03%. After the calculation of the eigenvalue, we move to the calculation of factor loadings and get unrotated matrix use. The method is extraction of principal components, and when you are carrying out analysis of factor loadings, you can get a table of factor loadings in which the 15 variables are classified into, or the variance contributed by the 15 variables is classified into three factors: factor 1, factor 2, and factor 3. And by way of this, you can attribute different variables into different factors. But in the present study, you can see that almost all the variables belong to factor 1, and it shows that the strong correlation between all these factors except one. 15 characters are discussed here: plant height of the peperomia plant, number of branches per plant, branch length, number of leaves per plant, internodal length, number of inflorescences, length of inflorescence, length of peduncle, leaf length, leaf breadth, petiole length, root length, number of roots, circumference of stem, and the fresh weight of the entire plant. Among these, only one character, the length of peduncle, shows the highest factor loading in the second factor, and all the other characters show their highest factor loading in the first factor. It shows that even though we have tried to extract three factors, these characters can be grouped into two groups only. And out of the 15 characters, 14 of them belong to the first factor and only one belongs to the second factor. Or in other words, even though each and every character contributes a considerable degree of variation to factor 1, factor 2 and factor 3, the highest contribution in the case of all the 14 characters is towards the first factor, and length of peduncle contributes more significantly towards factor. So here you have thus classified the 15 variables into two factors, two groups. And now the next step is to find out the variables that show the highest factor load. And from the table you can see that number of leaves per plant has got the highest factor load. The factor loading in the case of number of leaves per plant in factor 1 is 0.936, and it belongs to the first factor. And there are, of course, certain other factors which show a factor loading above 0.8. Plant height shows a factor loading of 0.84. Internodal length shows a factor loading of 0.83. Length of inflorescence shows factor loading of 0.80. Leaf length shows a factor loading of 0.84 again. Some values are positive, some values are negative. Anyhow, since it is the value related to the correlation coefficient of the character concerned, the variable concerned, the factor loading is either positive or negative, and leaf length contributes 0.84, of course, minus 0.84. Then leaf breadth contributes 0.809. The factor loading of root length is minus 0.85. The factor loading of fresh weight is minus 0.859 again. And among these variables, based on factor loadings, you can see that number of leaves per plant shows the highest value of factor load, and it is the most variable character, the most influential character in that particular group, in that particular factor. So you can say that it is the lead variable in that factor. And of course, some other variables come immediately below. And in the factor 2, length of peduncle only shows a considerably high factor loading, and it is minus 0.77, and contribution of variation of length of peduncle to the other factor groups is considerably lower than the contribution to the factor 2. And hence you can see that this is the lead character in the second group, and the relationship between the other 14 characters, the relationship between the other 14 characters is higher when compared to the relationship of length of peduncle with the other characters. Thus, you have extracted 3 factors and attributed the variables to 2 factors, and now you have found out the lead variables. And in further programs, further studies with this particular species of plant, for example, to study its distribution, its importance in terms of its performance, to find out techniques to improve the genetic base of the population, and also to carry out plant improvement programs in this particular species. You can confine to a few lead characters based on this analysis. And evidently, you can use number of leaves per plant as the most important character for your further studies. Length of pilgrimage stands perhaps alone, and it can also be equally and separately considered. And of course, other characters that show a factor loading above 0.8 can also be considered. So, from among the 15 variables, you can select 4 or 5 variables, and your further studies on your experiment, or your further studies on the Bromia populations can be restricted to these lead categories. So that is the importance of factor analysis, and it is highly useful, especially in biological sciences, and of course in social sciences also, where you can classify or you can group numerical phenomena into different groups, which are called factors, and factor analysis helps you to reduce the bulk of data, and it helps you to concentrate on a few important variables or a few important characters in further analysis procedures and further programs of study and research. Thank you.